Look at this kick. I think these droids have special physics. Like the normal physics doesn't apply to them. They can kick these things with special physics. Okay, so look how this thing flies. It doesn't look right.
Okay. Why doesn't it look right?
It's big and heavy, sure, whatever. But the way he kicks and the way it launches doesn't look right. Let's look at it one more time, then I'll break it down. Okay, so let's break that down a little bit, special physics.
Okay.
So here is the droid, KX droid, lifting up his leg. Here's like a knee, here's the hip. Here's that shin coming down.
Yep.
Okay, let's get another frame forward. Okay, he's extended the leg. So I think this was the foot, right? Wasn't there before.
So that means his foot can't get up underneath the lip at all. So he's kicking it from the top forward.
Right, it's like a straightforward kick, exactly. Here's the hip, here's the knee, his shin getting down, coming down the foot. So, but what actually happens? What would I think should happen? I think you should either tip the whole structure forward, or maybe you kick it a little bit and it tips forward a little bit, but it doesn't slide across the ground like this. I think in order to do that, you got to kick it low, like low below the center of gravity.
Yeah, so it's like if you move a glass across a table, if you push from the bottom, it slides. Nice.
Right.
But if you push it from the top, it just topples over.
Exactly. Okay. So now we know what it should be, but let's see what it does. So he kicks it from the top, like that's his foot. He kicks it from the top. But the way this thing launches, it launches from the bottom. The bottom lifts up.
Yeah, I see it.
I don't think that's right? Maybe maybe it's okay if he kicked from the bottom. Like kicking like a chair from the bottom, you get the tip back a little bit, and then it goes forward, and then rocks and stops.
Yeah,
that's not this.
Yeah, so if you kick it from the top, it's still in contact with the ground. You're not going to be able to lift it up in any way, which means the base, through friction, is going to stick on the ground. The top's going to move. It's going to flip over.
Exactly.
Okay.
And looking from the back, there's no way that he could have kicked it like somewhere here. There's just nothing back there. Like if this had been solid, then maybe a kick from there could do it. But it's not. We see the backside of it. And so I think that if you kicked it here on this top, it really should just tip forward.
Right.
Because exactly as you said, it's the front corner is the pivot point.
Right. And the center of mass is clearly, I don't know, below the foot.
Like down here somewhere, right?
Yeah.
You got all this heavy plate in the bottom. You get this heavy plate, which has its center of mass there, plus this center of mass down at the bottom, plus these things, the center mass is there. So overall, average it out, I'd say the center mass is somewhere like there-ish, fairly low, but in the middle.
So it's stuck to the ground on the bottom through friction. Its center of mass is below the foot, and you kick at the top.
Right.
That's all rotation.
Flat, solid here. Let's look at it. So I drew a picture. So if this is the A frame, you have the little window there, little window there. So the center of mass, I put it there, maybe.
Okay, reasonable.
So the center mass of this A frame is in the middle, but then you get that all heavy plate, so it's a little bit lower, and then you get a plate along this side, so it's a little bit, instead of being towards the back, it's towards the front, which means you get a torque that is in the plus theta direction. You get a torque that's coming out of the page. From the kick, from the kick is from up there, so you get a torque that's into the page. That's this way, right? And this force needs to be some enormous force, such that the static friction that is going in the left direction that is canceled out, and in fact the overall net force is way to the right, super fast, launched out there.
Right.
But I don't think that would have worked. I think this would have tipped over.
Yeah. So I think the kick force, it's easy for the android to provide enough kick force to overcome friction.
Yeah, sure.
But it's going to rotate.
I think so.
Yeah.
Yeah, so it didn't look right.
Didn't look right. Actually, let's watch it one more time. And now let's see. Watch the kick hit. It's going to move forward in a very unphysical way. Let's see.
Want to do some slow-mo? Here it is, frame by frame. All right. Droid walking up. Puts his knee up, shin up.
Kick.
Foot's up, kick. It launches forward, like it launches front, like launches up, like an airplane.
Right. No way.
Then it lands.
Boom.
It hits her out of the way. Boom.
Rebel.
Boom.
Rebel down. Or rebel up, then down.
And then here, can you see like that front corner is catching?
Yeah.
I think that would have happened right from the start.
Yeah.
And so this motion where it tips over, I think that's what should have happened.
Yeah. That's the exact motion we were looking for during the kick. Is that
exactly? And then it thuds, and there's no recoil.
So it's heavy.
Right? You see that? Like it thuds and no recoil.
Yeah. So it's heavy. So it's not some light thing that you could just like with some like foot friction just kick up off the ground. No, it's heavy.
Heavy thud, no recoil. Which I guess I don't know. I feel like it should have recoiled, should have cracked the ground or something. This is like stone, but maybe I don't know. I mean, this is going to be on screen for like half a second, like whatever. Just animate it, get it done.
Yeah.
I'm okay with that.
I agree. Yeah.
I'm okay with this part, but this part, the launch, that doesn't feel right.
Looks weird. Yeah, it looks. The more I look at it now, the weirder it looks.
Right? It's like a cat jumping. Not right.
Not right. I see it. Those androids, they dominate.
It'd be terrifying. It'd be terrifying to get in a fight with them.
Oh, for sure.